Imagine a beast born of iron and fire, a titan forged in the crucible of a desperate war, a machine so immense, so utterly gargantuan, that the very earth trembled beneath its treads. This is not a creature of myth or legend. This was a very real monster, a steel behemoth that weighed as much as a small naval destroyer, armed with a cannon that could obliterate any opponent from miles away, long before that opponent even knew it was in danger. This is the story of the Panzerkampfwagen 8, a designation that barely hints at its scale, a story hidden behind its deceptively simple code name, Maus. A name that belied its true nature, a name that was a whisper in a storm of steel and ambition, a name that belonged to the largest, heaviest, and most audacious tank ever built. Narrator. In the twilight years of the Second World War, as the tide turned inexorably against the Third Reich, a peculiar and fanatical obsession took hold of its leader, Adolf Hitler. An obsession with Wunderwaffen, or wonder weapons. These were to be the technological saviors of a failing regime, marvels of engineering that would snatch victory from the jaws of defeat. This was more than just a military strategy. It was a psychological crutch, a nationwide propaganda effort aimed at bolstering flagging morale, both on the home front and among the beleaguered troops. The narrative was that German genius would triumph over brute force, that a single technological leap could invalidate the enemy's numerical superiority. Across the crumbling empire, scientists and engineers toiled on jet fighters like the Messerschmitt 262, ballistic missiles like the V-2, and radical new U-boat designs like the Type 21 that could stay submerged for weeks. It was a time of desperate innovation, a national psychosis rooted in the belief that superior technology and sheer force of will could somehow overcome overwhelming numbers and catastrophic strategic disadvantages. And in this fever dream of technological supremacy, no concept was more emblematic of this obsession with gigantism than the super-heavy tank. A concept that would culminate in the creation of the Maus. If you are fascinated by the incredible stories of military history and the marvels of engineering, consider subscribing to our channel. We delve deep into the archives to bring you the most compelling and well-researched documentaries. The genesis of the Maus can be traced back to the brutal summer of 1941, during the opening phases of Operation Barbarossa, the German invasion of the Soviet Union. German panzer divisions, confident in their technological superiority after their swift blitzkrieg victories in Poland and France, were suddenly confronted by two new Soviet tanks that sent a shock wave of alarm through the Wehrmacht. These were the T-34 medium tank, with its revolutionary sloped armor which could cause shells to deflect, and the KV-1 heavy tank, a lumbering beast whose thick armor was almost completely impervious to the 37 and 50 millimeter guns of the standard German Panzer III and Panzer IV tanks. The primary anti-tank gun of the German infantry, the 37 millimeter Pak 36, was mockingly nicknamed the Heeresklopfgerät, or Army's door knocker, by the troops for its inability to penetrate the KV-1's armor. German soldiers nicknamed the KV-1 the Russischer Koloss, the Russian Colossus. Reports flooded back from the Eastern Front detailing harrowing encounters where German shells simply bounced off these new machines, sparking what became known as tank panic. This sudden technological challenge created an urgent, almost frantic demand for more powerful and more heavily armored vehicles. In response, a race began to create ever larger and more powerful tanks. Projects like the Panzer VII Löwe or Lion were initiated, exploring designs in the 75 to 90-ton range. But for Hitler, they were not enough. He was not interested in an incremental improvement. He envisioned a tank that was not just superior, but utterly invincible. A mobile fortress, a land battleship that could shrug off any conceivable anti-tank round and dominate the battlefield through sheer brute force and psychological terror. He wanted a weapon that would shatter enemy morale before it even fired a shot. He envisioned these leviathans breaking through enemy lines like unstoppable battering rams, impervious to any counterattack, creating gaps through which more conventional forces could pour. In a meeting on March 5, 1942, Hitler's vision was made clear. He demanded a tank that would be immune to any known enemy weapon and armed with a gun capable of destroying any target. The contract for this monumental undertaking was awarded to a man whose name was already synonymous with German engineering prowess, Professor Ferdinand Porsche. Porsche, the brilliant mind behind the iconic Volkswagen Beetle, was also a key figure in Germany's military-industrial complex, and a personal favorite of Hitler. He had a penchant for innovative, if sometimes overly complex and unconventional, designs, often favoring advanced electrical systems over traditional mechanical ones. Hitler, it's been suggested, may have awarded Porsche the contract as a form of personal compensation. Porsche's previous heavy tank design, the VK 45.01, had lost out in competitive trials to a more conventional design from the Henschel Company, which would go on to become the legendary Tiger I. Porsche's design had relied on a novel but troublesome gasoline-electric drive system that proved unreliable, prone to overheating and electrical fires. Awarding Porsche the Super Heavy Tank project was a way to keep his favored engineer engaged and utilize his considerable talents, despite his previous failure. The directive was simple, yet audacious. Create a 100-ton tank. Porsche, eager to please the Führer and vindicate his engineering philosophy, dove into the project, designated Type 205, with his characteristic enthusiasm. The initial design was codenamed Mammoth, or Mammoth, a fitting name for the beast that was beginning to take shape on the drawing board. However, in a display of what can only be described as ironic humor or a bizarre attempt at operational security, the name was changed in December 1942 to Mäuschen, or Little Mouse. Finally, in February 1943, it was shortened to simply Mouse. The Mouse. This seemingly absurd name was likely a form of misdirection, an attempt to conceal the project's true, colossal nature from Allied intelligence. One can only imagine the confusion of an intelligence analyst intercepting a message about a project named Mouse that required steel plates over 200 millimeters thick. The development of the Mouse was a collaborative effort, a testament to the capabilities of German industry even in the throes of a devastating war. The legendary steelworks of Krupp, a dynasty of German steel and armaments manufacturing for centuries, were tasked with the immense challenge of producing the hull and turret. This was no simple task. Casting and welding armor plates of such unprecedented thickness required specialized techniques and immense facilities. Final assembly would be handled by Alket, a firm experienced in assembling armored vehicles in Berlin. The heart of the beast, its engine, was to be provided by Daimler-Benz, the creators of the engines that powered Germany's fighter planes and naval vessels, and the innovative but complex electrical transmission system would be designed and built by Siemens. This was an all-star team of German industrial might, brought together to create an unprecedented weapon of war. As the design process progressed, however, the mouse grew, and grew, and grew. Hitler himself became personally involved, repeatedly demanding increases in armor protection. He was obsessed with making the tank invulnerable. At a meeting in May 1942, Porsche presented his initial design, which already exceeded the 100-ton specification. Hitler was pleased but, as always, wanted more. More steel, more protection. The initial weight of 100 tons soon became 120, then 150. Engineers voiced concerns about the practicality of such a vehicle, its immense ground pressure, its inability to use existing infrastructure, but their objections were overruled. By the time the final design was approved, the mouse had settled at a mind-boggling 188 metric tons. To put that into perspective, the fearsome Tiger I tank weighed a mere 57 tons. The American M4 Sherman weighed around 30 tons. The mouse was more than 3 times heavier than a Tiger, and weighed as much as 6 Sherman tanks. It was, and still is, the heaviest fully enclosed armored fighting vehicle ever built. Its dimensions were equally staggering. The mouse was over 10 meters long, 3.7 meters wide, and 3.6 meters high. Standing next to it would be like standing next to a small house. It was a land-bound battleship, a steel leviathan that would have dwarfed anything the Allies could field. And its armor was intended to be impenetrable. The hull front consisted of a 220-millimeter thick plate, sloped at an angle to increase its effective thickness against incoming projectiles. The sides and rear were up to 190 millimeters thick, designed to defeat flanking shots from even powerful anti-tank guns. The turret was even more heavily protected, with a cast, rounded front of 240 millimeters and 200 millimeters on the sides and rear. The gun mantlet, the protective shield around the main cannon, was a solid 250 millimeters of steel. To put this in context, the frontal armor of a Tiger I was 100 millimeters. The mouse was designed to be a moving bunker, impervious to the anti-tank weaponry of the era. It was believed it could withstand direct hits from any Allied tank or anti-tank gun then in service, including the formidable British 17-pounder and the Soviet 122-millimeter cannons, even at point-blank range. And what of its firepower? The mouse was armed to be as deadly as it was durable. Hitler insisted on a main armament of a 128-millimeter KBK 44L-55 gun. This weapon was adapted from a highly effective heavy anti-aircraft and anti-tank gun, and was one of the most powerful tank cannons of the war. It could fire a 28-kilogram or 62-pound armor-piercing shell at a muzzle velocity of over 900 meters per second. It was capable of destroying any Allied tank in service at the time, from a range of over 3,500 meters, a distance at which the mouse itself would be immune to return fire. This monstrous cannon was complemented by a coaxial 75-millimeter KWK 44L 36.5 gun. This secondary weapon, essentially the main gun of a Panzer IV, was intended to engage smaller, less armored targets like trucks or lighter tanks, allowing the crew to conserve the massive and limited supply of 128mm ammunition. The ammunition for the main gun was two-part, meaning the projectile and the propellant charge were loaded separately, a necessity due to their immense size and weight. For close-in defense against infantry, a 7.9 2mm MG-34 machine gun was also included. Inside the steel behemoth, the six-man crew, commander, gunner, two loaders, driver, and radio operator, would have faced a Herculean task, manhandling the enormous ammunition in the cramped confines of the turret. But building a tank of such immense size and weight presented a host of unprecedented engineering challenges. The most significant of these was the power plant. How do you move a 188-ton behemoth across a battlefield? A conventional mechanical transmission and steering system would have been impossibly large and complex to handle the immense forces involved. So Porsche, ever the innovator, turned again to his preferred solution, a gasoline-electric hybrid drive system. This was the same core technology he had unsuccessfully pitched for the Tiger tank. The idea was that a massive internal combustion engine would not drive the tracks directly. Instead, it would power a large electric generator located in the center of the hull. This generator would then produce electricity to power two huge electric motors located at the rear of the tank, and these motors would drive the tracks through a final drive gearbox. This system, in theory, offered several advantages. It provided immense, smooth torque for getting the massive vehicle moving, and it eliminated the need for a vulnerable, complex mechanical transmission and clutch system. However, it was also incredibly heavy, complex, generated immense amounts of waste heat, and had numerous points of potential failure. The copper required for the generator and motors was also a strategic material in short supply. The first prototype, designated V1, was fitted with a modified Daimler-Benz MB 509 V12 gasoline engine. This was an adaptation of the engine used in the Messerschmitt Bf 109 fighter plane, producing around 1,080 horsepower. The second prototype, V2, received a more advanced Daimler-Benz MB 517 V12 diesel engine, which was supercharged and had an output of 1,200 horsepower. This engine was adapted from a design intended for German U-boats. But even with these powerful engines, the Maus was agonizingly slow. Its power-to-weight ratio was a meager 6.4 horsepower per ton. For comparison, a Sherman tank had about 13 horsepower per ton. The top speed of the Maus on a hard, paved surface was a mere 13 kilometers per hour, or about 8 miles per hour. Off-road, in the mud and difficult terrain of a battlefield, it was even slower, often crawling at walking pace. This was not a tank designed for blitzkrieg-style warfare. It was a lumbering giant, a methodical, unstoppable juggernaut. The sheer weight of the Maus created a cascade of logistical nightmares. The most obvious of these was its inability to cross most bridges. The infrastructure of 1940s Europe, with its stone arch bridges and small country lanes, simply wasn't designed to support a 188-ton vehicle. To overcome this, Porsche's engineers devised a truly audacious and complex solution. The Maus would ford rivers by driving across the riverbed. For shallow crossings, its sheer height and sealed hull would be sufficient. But for deeper rivers, the Maus was designed to be fully submersible. A long telescopic snorkel would be raised to provide air to the engine and the six-man crew. and the tank would literally drive across the riverbed, submerged in up to 8 meters of water. This incredible feat required the tanks to operate in pairs. One mouse would remain on the riverbank, and its powerful generator would supply electrical power to the submerged tank's drive motors via a long, thick cable. Once the first tank reached the other side, it would disconnect the cable and prepare to provide power for its partner to cross. It was a brilliantly complex and utterly impractical solution to a self-inflicted problem, requiring perfect coordination and risking 2 of these priceless machines on every major river crossing. Transporting the mouse over long distances was another monumental challenge. It was far too heavy for any conventional truck or trailer. The only viable option was by rail, but even this required a specially designed 14-axle railway car, the Verlade wagon, to distribute its immense weight across the tracks. Even then, the routes had to be carefully planned to avoid weak bridges and narrow tunnels. Just moving a single mouse from the factory to the front would have been a major logistical operation, a conspicuous and vulnerable target for Allied air attacks. The logistical tale of the mouse was almost as gargantuan as the tank itself. The first prototype, V1, was assembled by Alket in December of 1943. As the specially designed Krupp turret was not yet ready, it was fitted with a concrete mock-up of the same size and weight for testing balance and the vehicle's suspension. The initial trials conducted at the Kummersdorf proving grounds near Berlin immediately revealed a host of problems. The engine, powerful as it was still underpowered for the vehicle's extreme weight and was prone to overheating. The complex suspension system, which consisted of multiple bogies on each side, struggled under the immense strain. The massive tracks, over a meter wide, were prone to breaking their pins and being thrown during sharp turns. The driver's visibility was poor, and the prospect of performing maintenance or repairing a 188-ton tank in the field under fire was a daunting one. A simple thrown track, a manageable problem on a smaller tank, would be a mission-killing disaster for a mouse. In fact, the design specified that if a mouse broke down and could not move under its own power, it would require 2 other mouse tanks to tow it to safety. In March 1944, the second prototype, V2, was delivered. It featured a number of improvements over the V1, including the powerful diesel engine and a redesigned suspension system from Skoda. In mid-1944, this prototype was fitted with the first production turret, complete with its formidable armament of the 128 and 75 millimeter guns. Further testing commenced, but the fundamental problems of the mouse's design remained. Engine failures were a constant issue, and the relentless Allied bombing campaigns hampered the production of specialized components, causing constant delays. One anecdote from the testing phase, however, highlights both the ingenuity of the electric drive and the immense challenges of the project. A prototype had strayed into a soft, boggy area of the testing grounds and became hopelessly stuck, sinking to half its height in the mud. For a conventional tank, this would have required multiple heavy recovery vehicles. After a team of soldiers dug away the surrounding mud, the electric motors were engaged at a very slow, controlled speed. By applying precise and immense torque to the tracks, the mouse incredibly managed to pull itself out of the mire, a feat that would have been impossible for a conventionally powered vehicle of its size. Despite the immense resources being poured into the project, the writing was on the wall. By 1944, Germany was on the defensive on all fronts. The strategic situation had changed dramatically since the Maus's inception in 1942. Influential figures like Heinz Guderian, the Inspector General of Armored Troops and the father of the Blitzkrieg, and Albert Speer, the Minister of Armaments, argued vociferously against the project. Guderian, a pragmatist, knew this slow-moving behemoth was the very antithesis of his successful doctrine of rapid, combined arms warfare. He saw it as a strategic dead end, a target, not an asset. Speer, as armaments minister, saw the immense drain on resources, precious steel, copper for the electric motors, skilled labor, and fuel, that could be used to produce hundreds of more practical and desperately needed Panther tanks or Stugee assault guns. For the cost of the two Maus prototypes, the German army could have received dozens of frontline tanks that were actually needed. In October 1943, the initial production order for 150 Maus tanks was officially cancelled. A month later, Hitler ordered a complete halt to the development of the Maus, with only the two existing prototypes to be completed for further evaluation and testing. As the war drew to its inevitable and bloody conclusion, the two Maus prototypes awaited their fate at the Kummersdorf proving grounds. As Soviet forces closed in on Berlin in April 1945, a decision was made to press the V-2 prototype, the only one fully armed, into service to help defend the facility. However, it seems it never saw combat. It was moved a short distance towards the nearby Zossen command post before breaking down due to mechanical failure. With the Red Army just miles away, the Germans decided to destroy the prototypes to prevent them from falling into enemy hands. The V-2 was sabotaged with explosive charges placed in its engine and fighting compartments. The resulting explosion was so powerful that it blew the massive 55-ton turret completely off its ring, leaving it a burnt-out hulk. The V-1, still fitted with its mock turret, was also damaged but remained more intact. When the victorious Red Army overran Kummersdorf, they found the two crippled giants. Imagine the awe and disbelief of the first Red Army soldiers stumbling upon these two machines. It would have been like finding alien technology. Intrigued by this monstrous creation of their defeated enemy, the Soviets decided to salvage what they could. In a remarkable feat of battlefield engineering, they used 6 captured German FAMO half-tracks, Germany's heaviest artillery tractors, to lift the 55-ton turret from the wrecked V-2 and mount it onto the more complete hull of the V-1. This hybrid Maus, a patchwork of the two prototypes, was then transported by rail to the Kubinka proving grounds near Moscow for extensive testing and evaluation. The Soviets were eager to understand its strengths and weaknesses, and their conclusions largely mirrored those of the Germans. Impressive, but impractical. Today, this sole surviving example of the Panzer VIII Maus is on display at the Kubinka Tank Museum, a silent steel testament to a dream of ultimate armored might. So, what are we to make of the Maus? Was it a visionary weapon that could have changed the course of the war, or a colossal waste of resources? The answer, unequivocally, is the latter. While its armor and firepower were undeniably formidable on paper, its practical limitations were overwhelming. Its slow speed would have made it a prime target for Allied fighter bombers like the P-47 Thunderbolt and the Hawker Typhoon, which had become masters of tank busting. Its immense weight and ground pressure would have confined it to roads and hard ground, making its movements predictable and channeling it into kill zones, and its immense fuel consumption, estimated to be around 3,500 liters per 100 kilometers, would have been unsustainable for Germany's crippled war economy, which was already starving for fuel. The Maus was a product of a specific mindset, a belief that bigger is better, that permeated Nazi military engineering in the late war period. It was a reflection of Hitler's obsession with grandiose war-winning weapons, a fantasy of technological invincibility that ignored the harsh realities of logistics, production, and battlefield mobility. The resources poured into the Maus and other super-heavy tank projects, like the competing E-100 and the truly fantastical Landkreuzer P-1000 Rata, a 1,000-ton land cruiser with battleship guns, could have been used to produce hundreds of more practical and effective tanks. It was a strategic dead end, a weapon designed for a war that Germany was no longer fighting. The Maus was a solution to a problem that didn't exist, a breakthrough weapon in an attritional war where mass production, reliability, and mobility were king. The story of the Maus is a cautionary tale, a lesson in the dangers of hubris and the folly of pursuing technological marvels at the expense of sound military strategy. It is the story of a tank that was, in many ways, a microcosm of the regime that created it. Immensely powerful in theory, but ultimately doomed by its own internal contradictions and a disconnect from reality. The Maus never fired a shot in anger, yet its legacy endures. It is a symbol of a time when giants walk the earth, a time of unparalleled technological ambition and devastating conflict. It is the story of the Maus that was meant to roar, but was ultimately silenced by the harsh realities of war. Thank you for joining us on this journey into the heart of one of World War II's most audacious and ultimately flawed creations. If you found this documentary informative and wish to see more deep dives into military history and technology, please consider subscribing to our channel. Your support allows us to continue telling these incredible stories. We have many more to share,